not busy because he had his ankle surgery, so he's on light duty.
Oh, yeah.
So he's not busy right now. But when he's not on light duty, he's on call, and so he gets called out all hours of the night. Yeah.
Mm.
Luckily, it's for a little tiny town in Arizona. Well,
Where?
not tiny
What town?
It's for Gilbert.
Oh, yeah, I know where that's at.
Yeah, so it's not tiny, but it's not. It's a good. It's like I think they said it was the second safest city in America.
Oh, that's nice.
So it's nothing really major happens, but whenever there's a dead body, he has to go to it and all that stuff. So.
Hey, Catherine, I was thinking about you. Where are you from in Texas?
It's like the southeast near the border of Louisiana, about 2 hours northeast of Houston.
Oh, were they affected by any of that flooding?
We really weren't. Houston was really bad, but my parents were pretty good.
Yeah, that's crazy.
Yeah.
It's crazy, crazy. Okay, well, I think we should get started.
Yeah.
Hopefully Abby will join in when she can.
That sounds good to me. So now, do we have to have anything open in the SPSS? Do we know?
I don't
yet?
know. I just opened it just.
Yeah, mine's open in case, so we'll go ahead and group meeting. All right, I'm starting. True.
I know. I'm so glad we always get the first two right. Makes me feel a little bit better.
Okay, in previous lessons, we have seen the population standard deviation sigma was known. In this lesson, we are making a different assumption about sigma. What has changed?
It is unknown. Okay, we got the first three right.
The null hypothesis is sigma equals 8, or shmu, sorry, equals 8, and the alternative hypothesis is shmu is greater than 8, and the population standard deviation is not known. Becca collects a sample of size n, or n equals 9, and computes x equals 11 and s equals 6. Use this information for questions 4 through 5. So is the sigma known? No. What is the value of t? Okay.
I've got it whenever you guys do.
I have it.
Oh, I am very slow this morning. Hold on.
Here.
Okay, 1.5?
Yep.
Yeah.
Okay.
Okay.
So, yeah, it looks like we are going to have to use SPSS. Okay.
Use values which are pulled from the data file, body temperature. Copy and paste them into the software you're assigned to use. Using the null hypothesis of mu is equal to 98.6 and the alternative hypothesis using mu is less than 98.6 and level of significance A is equal to 0.05. What is X?
My mind just went blank. Where do I go to find that one?
The analyze. I think that's right. And then the descriptive statistic would have it.
Where? Wait, where? Where am I?
No, analyze.
Wait, how do I find that exact one?
Then you highlight everything that you put down in there, and then you go to analyze, and then descriptive statistic, and then explore, and
Well,
then
oh no, I meant. Okay, hold on. Sorry.
The X bars are going to be your mean.
yeah.
Catherine, did you get yours?
Yeah.
Okay, you guys, how do I pull up that?
Okay, so go to Analyze.
No, not. I need. How do I pull up the quantitative inference?
The what?
That table.
Oh, I just copy and pasted the numbers they gave us in the homework.
Oh, I'm like, how do I pull this up? Okay.
So just copy those numbers and paste them into your SPSS, and it will pull it up.
Oh, okay. Gotcha.
Catherine, I got 98.22 as a mean.
Yeah, that's what I got.
Okay.
Okay, you guys are faster. 98.22.
Yeah.
Yeah. Did you put a 0 at the end of that or no?
So then you did analyze, descriptive, and explore, right?
Right.
So, sorry, I'm just making sure here I got it. And you're just looking for the mean of 98 point, wait, what did you guys get?
98.22.
Okay, perfect. Sorry, guys.
No, you're fine. And then the S is the standard deviation we would get with that.
Right.
So let me pull this down. 9.922.
Let's see, standard 0.922.
That's what I got. Is that what you got, Catherine?
Yeah, that's what I got.
Okay.
And what is the T-score? So that's where we pull up, I wrote this down. Analyze, compare means, unsample.
Oh, come on. Hold on, I have to go back to a large screen again because I just lost my...
And then our test value, because we have to put that in, is...
Okay, hold on. I have to close this out and do that one again. So, no. Okay, so for that we go up to Analyze, and we go to Compare Means, right?
Uh-huh, and then you do...
And then one sample test.
Yeah, and then remember to put in the test value of 98.6.
Oh, I thought it was... Hold on. I thought the test value was... You're right.
I was like, oh shoot, what is it?
No, it is. I am like, it's the mu, whatever that is.
Yeah.
But I had to like get out.
So the T-score I got negative 1.843.
Negative 1.843, yeah.
Okay.
Wait, why wouldn't we just use the equation?
Use the what?
The equation?
You can.
You can.
It's the same.
Yes. Because I used the equation and I got 0.206.
You got what?
0.206.
206. Let's see here.
Because for the X, I used the 98.22. And then I subtracted the mu, which was 98.6. then for the bottom, the S is the standard deviation, which is the 0.922, and N being 20, so that'll be the divided by the square root of 20. Oh, wait. I think I know what I did.
Yeah, the N would be however many those are, which is 20 of them.
I don't think I did the very last step. So wait, what'd y'all get?
Negative 1.843.
Okay, well, I got negative 1.845. So closer.
Yeah, I think somewhere in the book it said something about
It would be
that.
the same. Well, I guess I can just go with y'all's. It's probably right. I probably just rounded too early somewhere.
Okay, so when it says when mu is either less than or greater than, take the sig two-tailed one and divide it by 2 to find the p-value.
Oh, that's right. And this
so
is
0.081 divided by 2 is 0.041.
And that's for the p-value.
Yeah.
Yeah.
Because we're doing less than or greater than, right?
Yeah, so it's just the one-sided. So 0.081 divided by 2. 0.040.
I put 1. I rounded up.
Wait, what?
Because I had 0.0405, so I rounded up to 0.041.
Okay. Yeah. That's what I got.
Okay, so 0.041 is less than.
It's 0.05, so it's less than, so that means
reject it.
Reject it, yeah.
Right, Catherine? You got it?
Yeah.
You monitoring us and making sure we're doing it right?
Yeah.
Let's go with that.
Okay, use the following values. Okay, so now we do the same thing. So let me get this bigger and close this thing down. Delete all of these things. No, come on. Okay. And then highlight, copy these things. Copy. Paste. Okay. So are we doing the same thing? I didn't read the question. Copy and paste. Okay, the hospital claims the average time between births is 40 minutes and plans to resource allocation based on this claim. You want to test their claim. You select hypothesis of 40. Your first alternative hypothesis is not equal to 40. And you use a level of significance of 0.01. What is the p-value? Okay, so p-value is the t-score again, right?
No, p-value isn't the t-value, it's the significance.
Oh yeah. Oh, I mean that we have to go into the one sample test thing.
Yeah.
And that's how we get it, right?
Yeah, but
and change our thing to 40.
Yes, that's what I forgot to do though. So I need to change that to 40. And then, is it a one-sided? I don't remember.
It would be, I don't know. I just know because it's equal to, you use this sigma.
No, so it's two-sided because it's just not equal to.
It's not equal to, so it's 0.995.
Yeah. Oh, whoops, gotta find it. It is, yeah, 0.995 is what I got.
Okay, so we failed to reject it because it's greater than, right?
Yeah. Oh, so then we're just doing the one-sided, so we divide it so it goes lower so it decreases, right?
Yeah.
And if we decrease it, then you go the 0.995 divided by 2 equals 0.49. So then it's lower than the significance. So then we
reject it.
Okay, hang on. How did y'all do a P-score? Like, I know the number I'm getting is different than yours. So what am I doing wrong?
Okay, so are you in the SPSS, Catherine?
Yeah, I've got all that, and I went to the one sample t-test.
Okay, so then you look at the part that says SIG, and then in parentheses it says two-tailed.
Right.
So in the book it tells you that if the mu does not equal, then you take just the SIG two-tailed number.
Yeah, I know all that. My number is different. I don't know why.
Well, did you change your test value to 40?
40. No.
Yeah, so go back, so close out what you have right here, and then go back and redo it again, and in that little box you'll change it to 40.
Okay. Okay, no, why is it 40?
Because that's our test value on this one, because we changed it instead of the 98.6.
Yeah, so the mu is now 40. So when you go in,
I got it now. Okay, 0.995.
yeah, okay.
Yeah. I know,
Yeah,
you've got to just remember to...
Yeah, that's what I was telling you, Catherine, that I'm like, I got so confused on that one part is when I forgetting to change that thing, the test value. That's what I was talking about. But once I figured that out, that I was doing that, I got it. Okay, so compare the width of the confidence interval for question 11 to the confidence interval for question 13.
Which one is wider? So it was, oh my gosh.
Okay, so 0.995 and 0.498.
Yeah.
So, hold on. I wrote this down.
What number?
15.
The last one.
Oh, wait, okay.
Hold on, I wrote this down somewhere.
Okay, and then explain it to me, because my mind just went blank on that one. Which one is wider? Wait. Degrees of freedom. Oh, no.
It's going to be question 13 is wider.
Question 13. Okay, why? Because I'm confused.
Because it said, as the degrees of freedom increases,
Uh-huh.
then it gets closer and closer to a regular bell shape because the T distribution has the more area under the two wings.
The tails.
Mm-hmm.
And it goes up. So as the degrees of freedom increases, then
it's getting closer to the regular bell shape, which would make
It'll get smaller, the
more area under the tails. And so that would make the confidence interval wider, I'm pretty sure.
So I have to draw it on the map. So wait, when the tails get bigger, it's bigger up here? Is that what we're saying? What is it?
It's in the book, hang on. Like the very book, it gives us like 3 different graphs.
Okay. Okay, let me pull up the book. Hold on.
Because maybe it stays the same. Because looking from each one, they don't really
Okay, so what's the question again?
Which one is
I'm
wider?
on another screen. Okay.
The question is compare the width of the confidence interval for question 11 to the confidence interval for question 13.
Okay, this was on our preparation assignment. how does the margin of error of the 95% confidence interval compare to the 99% interval? And hold on. Well, those are with the 2. So those.
So
we
okay,
don't have a confidence interval. How do we figure that out?
I know, because it's not the degrees of freedom, right? It's the confidence interval is what we're looking at.
Yeah, that's why. Okay. Then
Right?
you know what?
Okay.
Let's just look at our work because it tells us the upper and lowers.
Oh, is that all we need to do?
I mean, it does. It tells us, okay, so.
Oh, hold on. Okay, how did to find the p-value? Okay. Hold on, I'm just reading in the book.
A quick question. What did y'all get for 14?
Wait, what did we get for what?
14?
Hold on, I'm. Sorry, I have to pull it up because I'm on a different screen. 13?
14.
I got decrease.
No, we got 14. It's 13 is the decrease.
Reject.
Reject it.
Yeah, because it is less than the point, whatever it is.
Whatever.
Yeah, the 0.05 or.
And number 12 was fail to reject, right?
No, 12 was failed to reject because it was a 0.995, so it's higher than.
Because the width of the confidence interval in like that middle section, not including the wings, right?
Yeah, it's the middle section. I'm just looking at the
I'm looking through the text to see here.
No.
But
I'm looking at the t-test statistics sample.
Would it just be the same? Because I mean, we're using the same graph. We're just using a different section of it. We're using one tail instead of 2 tails.
Yeah, I'm going to pull, yes, because it tells you, okay, so when you look at the actual t-test on the SPSS, the statistics,
Right.
it tells you the 95% confidence interval of the difference. You have your lower and your upper. So our question is asking us our confidence levels. Well, even it doesn't matter because the confidence interval doesn't change. The only thing that changes your t is if you're using one side or 2 sides.
Yeah, that's what I was thinking.
But the confidence interval doesn't change at all.
fine. Okay, because we're still doing the 95% confidence level, and that's what 95% confidence level is. That's what you're saying.
Yeah. So if we change it to 99%, that's a different story. But because we keep it at 95% confidence interval, that doesn't change. The only thing that changes is what we're looking at on our graph.
So compared to the width of the confidence level interval for question 11 to the confidence interval for question 2, which one is
They're the same.
Same.
Because our confidence level is still the 95%.
Right.
Yeah, it doesn't change whether we're looking at 2-tailed or 1-tailed. Because if you just look at your t-test...
But it's saying compare the width of the confidence interval.
Yeah, it doesn't change.
Is that saying how big the lower and upper one is?
No, what it's the confidence interval is like the width of that middle section on the graph. And since we're not changing the graph, then the width of the middle section doesn't change.
Okay. I gotcha. Okay. So we'll say they are the same. Okay, I'll go. Submit. Yes. Oh, you guys, 94%. So I got one wrong, and it is the, ooh, did I do it wrong? Okay, 14. What did you guys put on 14?
Reject.
Reject.
It's failed to reject because it's lower. You guys, we knew that because it was 0.49.
Which is still higher than the .01. So yeah, it would fail to reject.
Yeah. So it's failed to reject, but they are the same on number 15. So.
Okay, well, I wonder where Abby went. Hopefully she'll...
Yeah.
Because she didn't even pop on at 8:30 either.
Yeah. So next Tuesday, do you guys want to do 9 or 9:30?
It doesn't matter to me. My kids aren't in school.
Either one's fine for me.
So whatever works best for you.
Well, my kids are out of school next week, so it won't matter for me. So it will be craziness no matter what. So should we just...
It doesn't matter.
Let's just do 9 since that seems to be easier for you, Holly, and
Okay.
my kids might be doing their jobs at that time, hopefully.
Yeah.
Their chores. And so
Mine are